Have you ever wondered how machines make decisions? How can they predict if an email is spam or not? Or if a transaction is fraudulent? The answer is often logistic regression, a cornerstone of machine learning and data science. Logistic regression is a statistical model that, in its basic form, uses a logistic function to model a binary-dependent variable. But what does that even mean? It might sound complicated, but fear not. We'll break it down step by step. At its core, logistic regression is a type of predictive analysis. Like linear regression, it's a way of understanding and predicting outcomes based on certain variables. However, while linear regression predicts continuous outcomes, logistic regression is used to predict categorical outcomes, usually binary ones. Think yes or no, true or false, win or lose. The first step in logistic regression is to have a set of data. This data should have one binary outcome variable that you're interested in predicting, and one or more predictor variables that you believe may influence the outcome. Next, it's time to apply the logistic function. This function takes any input and transforms it into a value between 0 and 1. This value can be interpreted as the probability of the outcome occurring. For example, if you're using logistic regression to predict whether an email is spam, the logistic function might take in various factors like the sender, the subject line, and the time of day, and output a number. If that number is 0.7, we can interpret this as a 70% chance that the email is spam. After applying the logistic function, it's time to use your data to estimate the coefficients of the logistic regression equation. This is typically done using a method called maximum likelihood estimation, which finds the coefficients that make the observed outcomes most likely. Once you have your coefficients, you can use them to predict the outcome for new data. Simply plug the values of the predictor variables into the logistic regression equation, apply the logistic function, and interpret the result as the probability of the outcome. So to summarize, logistic regression is a type of predictive analysis used to predict binary outcomes. It involves using a set of data to estimate the coefficients of a logistic regression equation, which can then be used to predict future outcomes. The beauty of logistic regression lies in its simplicity and versatility. It can be used to predict outcomes in a wide range of fields, from healthcare to finance to marketing and beyond. And despite the rise of more complex machine learning algorithms, logistic regression remains a powerful tool in the data scientist's toolkit. By understanding logistic regression, you've taken a significant step in the journey of understanding how machines learn and make predictions. Take a moment to appreciate the elegance of this method and the power it holds in shaping the world around us. Remember, in the world of data, it's all about finding patterns and making predictions. And logistic regression is one of the most important tools we have for doing just that.